Poor spanning tree protocol. It gets really picked on in the data center. There's a wide variety of technologies that literally edge spanning tree protocol right out of your network infrastructure. In this nugget, we'll explore one of those technologies called virtual port channels. In the exam environment, you're responsible for an intense knowledge of these virtual port channels, as well as being able to demonstrate that you could verify a configuration is healthy and also particular details of that configuration. Let's jump in. So let's jump to it. We want to know exactly why we have this particular technology. We want to know intensely how it works. And then, as I promised you, we need to be able to verify the configuration. And that's very simple, but let's just run through it quickly at the end of this nugget. So let's say we've got a couple of Nexus 7000s, and downstream we've got a couple of Nexus 5000s. Here you can see the cabling scheme, and it's no surprise, right? Each of the 5000s makes a connection to one of the two 7000s. This is great from a redundancy perspective. We are cabling in the form of triangles, as we are so used to doing in our network designs. Now, one of the issues here is, of course, spanning tree protocol. In an ordinary world, spanning tree protocol is going to come in and it's going to block a particular link to guard against loops. Obviously, this is not a preferred type of configuration. Now think about what you could do in an iOS world. In an iOS world, you would go in and you would go ahead and make an ether channel bundle between devices, between links that are going to be bundled together to full spanning tree protocol into thinking you have a single link and not doing that blocking, right? So in a iOS, in an earlier type of world, we would ether channel. But of course, we can't do that on the 5K in that traditional world because we're not making two connections to the same upstream device. We are making connections to different upstream devices. All right, well, get ready, folks. Virtual port channeling is going to allow you to bundle these links together. In fact, from the 5K perspective, this device up here is one big virtual switch. Yeah, the 5K thinks it's making a connection to one upstream device and is able to bundle those links together in what we call a virtual port channel. This is great because now we can take advantage of all of the features of our regular old ether channels. Like we can go ahead and load balance across these links. We can enjoy the combined bandwidth effect of these links to the different upstream devices. Should there be a failure of one of these 7000s, well, for the downstream device. Now, really, the most important connectivity element here is the virtual port channel peer link. It's going to create the illusion of a single control plane between these 7000s. It's going to forward bridge protocol data units, link aggregation and control packets, and it's going to be allowing communications between one of our 7Ks that is considered primary and another 7K that's considered the secondary virtual port channel switch. One of the things you can do, as you might guess, is you can influence which of the devices will be the primary virtual port channel peer and which will be the secondary. The peer link is also going to be key for synchronizing our MAC address tables between these peers and synchronizing IGMP entries for the purposes of IGMP snooping. Notice that this peer link is going to go ahead and support the transmission of multicast traffic. And when we have orphaned ports in our environment, it'll transmit the traffic of those orphan ports. Orphan ports, notice, are ports that aren't participating in the virtual port channel infrastructure, but of course they can still make their connectivity to these 7000 series devices. Notice also the peer link is going to go ahead and provide HSRP transmission of packets if we're dealing with a layer 3 switch type infrastructure. Now, obviously, there needs to be synchronization information for stateful type configurations between these devices for all this to work. And Cisco named this particular set of messaging Cisco Fabric Services. So be aware if you see the acronym CFS associated with virtual port channels, we are talking about the set of technologies that really make this work. All of the messages that would be required to make this synchronization work, and we refer to this with the umbrella term Cisco Fabric Services. By the way, before I really leave this concept of the virtual port channel peer link that is so important, let me point out too that this link can, in circumstances, carry unicast traffic. It will do this under failure scenarios of other links in the virtual port channel topology. So you could have your peer link carrying unicast traffic in your Nexus environment. Now, one of the things that's offloaded from that important peer links set of responsibilities is keep alives. Notice we have a separate keep alive link. It's called the virtual port channel peer keep alive link. And this logical link typically runs over an out of band network. So we'll often see the acronym OOB associated with this link for out of band. It's going to provide the layer 3 communications path that's used as a secondary test to determine whether or not the remote peer is operating in the correct fashion. Notice that we don't send data over this link. We don't send particular synchronization messages over this link. It's really just a link to determine the status, the health of the peers in the virtual port channel peering. Now, how about the virtual port channel itself? Well, you can see here it is, right? It's those links on the two separate 7Ks that lead down to the 5K. Notice on our 5K in this example, we have just a plain old ether channel configuration, right? So nothing fancy going on the 5K. It's just got a ether channel bundle, but the magic happens upstream with the virtual port channel technology. And obviously, when you have a particular port that's participating in a virtual port channel, we refer to this port as a member port. We contrast this to a port that's connecting out to some device that's not participating in the virtual port channeling, and we call that an orphan port. Now, everything that you see on screen, all these ingredients that make up our virtual port channel infrastructure, all of this is considered as part of a vPC domain. In fact, in the configuration of the virtual port channel, one of the key things that we have to do is assign a domain ID. This is a numeric identifier for our virtual port channel domain. Now let's talk about some caveats. Let's talk about some limitations. Remember that peer link that we spoke of? Such a critical component, and we see it connecting these 7Ks. It has to be a 10 gigabit Ethernet port. So this is 10 gigabit ports. In fact, it's recommended that we use at least two 10 gig E ports for this dedicated functionality in the virtual port channel environment. Also, please keep in mind that port channels are a per virtual device context function. So we can have port channels extending across different virtual device contexts. If you are fuzzy, if you're vague, if you're having trouble with this concept of a virtual device context, have no fear. We will get into that in greater depth in the CCNA data center. And of course, we get into all Yeah, think about it now. We can do virtual port channels going this way upstream to our 7000s, and then on the other side of this equation, we can do virtual port channels down to the 2Ks. This is often called a dual sided virtual port channel configuration, and it's great, right? We know these 2Ks are already acting like line cards in the 5Ks, and now what we can do is set up virtual port channels so that we have this awesome redundancy and load sharing type of an environment. So we can do virtual port channeling top to bottom throughout the data center infrastructure and completely minimize, engineer out spanning tree protocol from the equation. Oh, by configured on this device is 1. What is that virtual port channel? It's down here. It's got an ID of 20. It's port channel 20 is what we've named it. It's up. Its consistency is a success because of the reason everything's successful. And we're allowing VLANs 1 through 100 over this virtual port channel. Now, how about the peer link? The peer link is port channel 10. It is up, and sure enough, it's going to allow those 100 VLANs across its particular link. Next up, it's our show VPC peer keep alive command. Notice, by the way, you could see all of these available commands just by doing a show VPC and then utilizing the question mark, of course, for context sensitive help. Here, with the keep alive command, or peer keep alive command, I should say, obviously we're seeing details about that keep alive status. Notice focus on whether or not your peer is alive, very first line, how long that particular peer has been alive, and what interface are you using for this particular peer keep alive functionality. Notice it's very common that we'll use the out of band management interface, as we said earlier in this nugget. Something else I want you to be aware of is the particular keep alive parameters you've set. What are you sending these keep alive messages to from an IP address perspective? What's the interval? What's the timeout? What's the hold time? What's the VRF you're using? What UDP port are you using? And finally, the keep alive type of service. Notice the display of this type of service setting is actually using the full 8 bits of the toss byte, right? So this is a decimal representation of those 8 bits set in the toss byte. Now, what about checking the particular role of the device run? I mean, we saw we got information about our local device when we did our show VPC brief, but what if we want information, more detail about the particular role? Well, notice on this particular device, we have a role of secondary. We can see that our local role priority value is set to this number. Lower is better on these particular settings. So if we're in an environment where we want to check the priority values that an administrator has set for the primary and secondary roles in the virtual port channel domain, show VPC role is going to be a very easy way for us to check that information. Again, the two things I'm interested in you mastering here are what is our role and what is our role priority setting. Now, the final verification command I want you to be aware of is show VPC consistency-parameters. Notice you can specify an interface or you can look at things globally with this command. This is so cool. This literally shows you important local values for your VPC setup, like are you using a 10 gig link? Is it full duplex? Is it trunking? What's the allowed VLAN list? And it compares that to your peer. Obviously, we need twins here in the configuration, and this command is going to isolate any non-matched settings, what we would call non-consistent settings. So what a valuable command as we're doing our troubleshooting of our virtual port channel environment. So in this important nugget, we took a look at virtual port channels. We discovered why they're so preferred. We discovered the technology behind these particular virtual port channels, and we wrapped it up with a look at how we would take a virtual port channel domain and verify it. All of the commands that we must master all begin show VPC. So remember, when in doubt, show VPC question mark, and you'll see those great commands we looked at like show VPC brief, show VPC role. All those wonderful commands that we examined for really determining the configuration and the health of your virtual port channel domain. Well, I hope this has been informative for you, and I'd like to thank you for viewing.